So here we have the trigonometric function 1 minus x squared divided by sine 2 pi of x. So we've defined its limiting value. So let us begin by doing a direct substitution for the value of x. So we have 1 minus 1 squared, which is 1, divided by sine 2 pi. Now the value of the numerator will be 0, and the value of the denominator, which is sine of 2 pi, that's also 0. So this is giving us an indeterminate form of 0 over 0. So we will need to simplify our function. But before doing that, what we are going to do is we are going to change the limit from x to h. So we have h going to 0. So that would mean we'll also need to replace the value of x by 1 plus h whole squared. And so we'll have sine 2 pi times 1 plus h. So let us simplify the numerator. So we have 1 minus, so 1 plus h whole square is an identity. So we can expand it as 1 squared plus 2 times 1 times h. So that will be 2h plus h squared. Whole thing divided by sine 2 pi plus 2 pi h, which will be equals to limit h approaching 0, 1 minus 2h minus h squared divided by, now we have sine 2 pi plus theta, so sine 2 pi plus theta is equals to sine theta. Now since we are in the first, this is the first quadrant, 2 pi plus theta. So first quadrant means all the trigonometric functions are going to be positive. So we get positive sine theta. So we have sine 2 pi plus 2 pi h. So that is going to give us sine 2 pi h. Now we can cancel the 1 in the numerator. So we have 1 and gone, 1 and negative 1 cancelling out each other. So that leaves us with limit h tends to 0, negative 2h minus h squared divided by sine 2 pi h. Now what we are going to do is we are going to divide both numerator and the denominator by h. So we get limit h approaching 0. So negative 2h divided by h is going to be negative 2, and negative h squared divided by h is going to give us negative h divided by sine 2 pi h divided by h. Now we are going to multiply h with 2 pi. So that would mean we'll also need to multiply the entire denominator by 2 pi. So 2 pi is an extra factor. So this has been done so that now we can apply our limit to both the numerator and the denominator separately. So we have limit h tending to 0, negative 2 minus h divided by limit h approaching 0, sine 2 pi h divided by 2 pi h, and we have the constant term which is 1 over 2 pi. Now we apply the limits. So our numerator will be negative 2 minus 0 divided by, now we have sine 2 pi h over 2 pi h. So the limiting value is going to be 1. So here we're using the definition that limit when x tends to 0, then the value of sine x over x is simply going to be equals to 1. Then we have the constant term which is 1 over 2 pi. So that finally gives us negative 2 over 2 pi. The 2 and 2 gets cancelled out. So we have minus 1 over pi. So this is the limiting value of our given function when x tends to 1. Let us move on to the next question. So here we have the trigonometric function 1 plus cosine of pi of x divided by 1 minus x whole square, and we need to determine its limiting value when x approaches 1. So let us begin by doing a direct substitution for the value of x. So we have 1 plus cosine of pi in the numerator divided by 1 minus 1 squared in the denominator. Now cosine of pi is -1, so we have 1 minus 1 divided by 0 squared. So this is giving us an indeterminate form of 0 over 0. So this means we will need to simplify our given function. But before doing that, what we do, we are going to change the limit from x to h. So we have h tending to 0. So that would mean we will need to change the value of x. So x gets replaced by 1 plus h divided by 1 minus of 1 plus h. We have whole squared. So this will be equals to limit h approaching 0. We have 1 plus cosine of pi plus pi times h divided by, so 1 and 1 gets cancelled, so we are left with -h whole squared. Now cosine of pi plus theta is equals to cosine of theta, and cosine and pi plus theta is in the third quadrant. So in the third quadrant only the tangent function is positive, so that means we'll have negative of cosine theta. So that now our function becomes limit h tends to 0. So we have 1 minus cosine of pi of h divided by h squared. Now we're going to use the identity. So we know that 1 minus cosine of theta is equals to 2 times sine squared theta over 2. So if we replace theta by pi of h, so we are going to get 2 times sine squared pi of h over 2. So let us substitute this value into a given function. So we'll get limit h approaching 0. So we have 2 times sine squared pi h over 2 divided by h squared. So let us rearrange it. So we have 2. So 2 can be pulled out from the limit. So we have 2 times the limit. It's going to 0. Sine pi of h over 2 divided by h whole squared. Now what we will do, so we need a pi h over 2 in the denominator, so we only have an h, so we're going to multiply h by pi over 2. Now, so that would mean we'd also need to multiply the entire function by with pi over 2. So that gives us limit 2 times the limit h approaching 0. So we have sine pi h over 2 divided by pi h over 2 whole squared multiplied to pi squared over 4. So that becomes 2 times pi squared over 4 is simply pi squared over 2. So what we have done, we have factored out 2 from both the numerator and the denominator. So our final limit becomes limit h tending to 0 sine of pi h over 2 divided by pi h over 2 whole squared. And we know from the definition of limit that the limiting value of sine theta over theta when theta tends to 0 is going to be equals to 1. So we have pi squared over 2 times 1. So our limiting value is equals to pi squared over 2. So this is the answer. Let us move on to the next question. So here we have the trigonometric function sine of 2x minus 1 divided by x minus pi over 4. So we find its limiting value when x tends to pi over 4. So we have sine 2 pi over 4 minus 1 divided by pi over 4 minus pi over 4. Now sine 2 pi over 4 is simply sine pi over 2 minus 1 divided by 0. Then sine pi over 2 is 1, so we have 1 minus 1 divided by 0, which is giving us an indeterminate form of 0 over 0. So let us change the function by changing the limits. So we have limit h tending to 0 sine 2 times, so x will get replaced by pi over 4 plus h minus 1 divided by pi over 4 plus h minus pi over 4. So that is going to give us limit h tending to 0. So we have sine 2 times pi over 4 is going to be pi over 2 plus 2h minus 1 divided by, so the pi over 4 gets cancelled, so we have h in the denominator. Now limit h tends to 0, so we have sine pi over 2 plus theta, so this becomes cosine of theta, so that means we have cosine of 2h, but we are in the second quadrant, so this is 90 plus theta. 90 plus theta means we are in the second quadrant where sine is positive, so we'll have positive cosine of 2h minus 1 divided by h. Now we're going to use the identity where 1 minus cosine of theta is equals to 2 sine squared theta over 2. So that gives us limit h approaching 0. So we have cosine of theta minus 1, so we can take a negative as the common factor. So we have negative 2 times sine squared, so 2h over 2 is going to give us h divided by h. So now we're going to multiply the numerator by another h, so that will make it h squared. So that means we have to multiply the entire function by h. Now this will become evident in a moment why we have multiplied by h. This has been done so that we can apply the definition of limit. So we have sine h over h whole squared multiplied to 8, so we can apply the limit to the function h as well. So as per the definition, the limiting value of sine h over h is going to be 1, so we have negative 2 times 1 squared, and the limiting value of h is going to be 0. So this gives us the value of 0. Let's move on to the next question. So here we have another function, so we have to find its limiting value when x approaches negative 1. So when we do a direct substitution for the value of x, we're going to get the indeterminate form of 0 over 0. So let us begin by changing the limit. So we have limit, for we're changing from x to h, so we have h going to 0, such that the x now will become negative 1 plus h whole squared minus negative 1 plus h minus 2 divided by, so we have x squared here, so that would be negative 1 plus h whole squared plus x, which will be negative 1 plus h minus sine of negative 1 plus h plus 1. Now we expand the terms in the numerator, so we have negative 1 plus h whole squared, so that will be negative 1 squared plus 2 times negative 1 times h plus h squared. Negative times negative 1 is going to be positive 1, and we have negative h minus 2 divided by negative 1 squared plus 2 times negative 1 times h plus h squared minus 1 plus h minus sine of h. The 1 and negative 1 gets cancelled for the argument of h sine, which will be equals to limit h tending to 0. So negative 1 squared will be 1. 2 times negative 1 times h will be negative 2h plus h squared plus 1 minus of h minus 2, whole thing divided by 1 minus 2h plus h squared minus of 1 plus h minus sine of h. Now we combine all the like terms, so that is going to give us limit h approaching 0. So here we have positive 1 added to positive 1, so that will be 2. So we have 2 minus 2, so that gets cancelled. Then we are left with h squared. We have negative 2h, negative h, so that will be negative 3h. Divided by, so the 1 and 1 gets cancelled. So we have h squared minus 2h plus h, so that will be simply h minus sine of h. Now we are going to divide the numerator and the denominator by h. So that gives us limit h tending to 0. So h squared over h is going to be h minus 3h over h. So that's going to give us 3 divided by h minus 1 minus sine h over h. Now let us apply the limit to each one of them individually. So we have limit h approaching 0 to h minus 3 divided by limit h approaching 0, h minus 1, minus the limit h approaching 0, sine h over h. So in the numerator, we're going to get 0 minus 3. So we have negative 3 in the numerator, divided by limit of h minus 1 will be 0 minus 1, which is negative 1, minus sine h over h. The limiting value is going to be simply 1. So that leaves us with negative 3 over negative 2. So we multiply both numerator and the denominator by negative 1. So that is going to give us 3 over 2. So this is going to be the limiting value of a given function when x approaches negative 1. Let us do another problem. So this problem is somewhat similar to the previous one. So we are going to determine the limiting value when x approaches negative 2. So this time what we're going to do, we're going to factorize the numerator. So we have limit x approaching negative 2. So we have x squared minus of x minus 2. So we can factorize it by splitting the middle term. So that will be x squared minus of 2x plus x minus 2. So we can take x as the common factor from the first two terms. So we're left with x minus 2. Plus taking 1 as the common factor from the last two terms. So we'll have 1 multiplied to x minus 2. Then that would leave us with x minus 2 times x plus 1. And we also have an x squared minus 2x in the denominator. So if we take x as the common factor, so we'll be left with x minus 2. So let us substitute this value into our given function. So we have x plus 1 multiplied to x minus 2. So that becomes our numerator in the factorized form. And x squared minus 2x will become x multiplied to x minus 2 plus sine of x minus 2. Now we are going to change the limit from x to h. So that is going to give us so there's a small mistake here. This is not x tends to not negative 2, x tends to positive 2 here. So we have a positive 2 here. So we have limit h tending to 0. So our x will now get substituted with 2 plus h plus 1 multiplied to 2 plus h minus 2. Similarly, the x gets replaced by 2 plus h in the denominator as well. So we have 2 plus h multiplied to 2 plus h minus 2 plus sine 2 plus h minus 2. So this becomes limit h tending to 0. So we have h plus 3 times h in the numerator divided by h times 2 plus h plus sine of h sine. So this is what we get. Now we're going to divide the numerator and the denominator by h. So we have, so that will be limit h approaching 0. So we divide the numerator and the denominator by h. So that is going to leave us with h plus 3 in the numerator. And we have 2 plus h in the denominator plus sine h over h. Now we're going to apply the limit. So we have limit h tending to 0, h plus 3 divided by limit h approaching 0, 2 plus h plus the limit applied to the function sine h over h. So when we apply the limit, so we have 0 plus 3 in the numerator, that will leave us with 3, divided by 2 plus 0, which is simply 2, plus sine h over h, so the limiting value is 1, so we have 3 over 3, so our limiting value is